All right, hi everybody. Today we're going to go over molarity calculations, and then in our next video we'll go over molality calculations. I'm going to split them into two, mostly just to keep them kind of short so you can kind of work on one at a time. I'm not going to go over percent mass or percent by mass calculations. The document I'm handing out to you for homework and practice has a really good breakdown of how to do other types of concentration calculations. I really just want to touch base on molarity and molality for now. So what we're going to start with is our given problem. Our first problem says we have 3.5 liters of solution and we have 90 grams of sodium chloride. And then the thing that we're asked is, what is the molarity of the solution? So in order to do this, we want to make sure we have identified all of our given unknown information. We were given 90 grams of NaCl. We were given the volume of the final solution. Our goal is to get molarity of the final solution. So in order to do that, I want to remind you that our molarity formula is going to be that molarity will equal the moles of the solute divided by the liters of the total solution. Okay, so in order to do this, it looks like we're going to need our solute to actually be in moles. And it looks like this guy is already good. It's already in liters. So in order to get our first one, our given grams of NaCl into moles, first thing we're going to do is we're going to go from grams to moles. And if you do not have your periodic table and your calculator handy, I'm going to give you a second to get that. I will be right back. Okay, we're going to go ahead and we're going to continue. I had to pause and get my periodic table out so that I could find the molar mass of NaCl. According to my periodic table that I have right in front of me, sodium weighs 22.990 grams. Chlorine weighs 35.453 grams. We add them together. Don't forget to keep your 3 decimals like we've talked about in the past. You're going to get a molar mass of 58.443 grams over 1 mole. Don't forget that that's what a molar mass is. So for us, we're actually going to take the flip of this. Remember that these can be written either way. And I'm going to put that over here so I can get my grams of NaCl into moles of NaCl. Doing that, I'm going to end up with 1.539996 moles. Kind of round that to 3 decimals, 1.540 moles of NaCl. Okay, so that is our number of moles of NaCl. I'm going to put that number up here, and then I'm going to erase a few things to make myself some room. Oh, please. Think of elevator music while I do this real quick. Okay. From there, we're going to do our actual molarity calculation. Please do remember that molarity gets a capital M as a unit. We're going to take our 1.540 moles of NaCl. We're going to divide it by the 3.50 liters. And we're going to get a molarity of 0.440 moles per liter, which is 0.440 moles. All right, problem number 2. Problem number 2 says we're given 0.8 liters of a 0.5 molar HCl solution. How many moles of HCl does this contain? So we're going to define our given and our unknown. We're given the volume of the solution. We're given the concentration of molar solution of HCl. We want to calculate the number of moles. So again, I'm going to remind you that molarity equals moles over liters. And I'm going to look for the given number of moles given the molar of the solution and the liters of the solution. So really this one I don't have to do any conversions. I just have to plug in what I know. So I'm going to take the molarity of the solution, which is 0.5 molar, and I'm going to set it equal to X number of moles because I don't know. And I'm going to put that 0.8 liters on bottom. From here, I'm going to solve for X. So I'm going to multiply both sides. And I'm going to get 0.5 times 0.8 equals 0.400 moles of HCl. Don't forget our 3 decimal place rule. That was problem 2. Moving on to problem 3 on molarity. This one says to produce 40 grams of silver chromate, you will need at least 23.4 grams of potassium chromate in solution as a reactant. All you have on hand is 5 liters of a 6 molar potassium chromate solution. What volume of the solution is needed to give you the 23.4 grams needed for the reaction? Okay, so let's break this problem down into our given and our unknown. Our goal is volumes in a solution, and so we're going to go through and we're going to look again at molarity. We know it's a molarity problem. We're going to put moles over volume in liters. We know that we have the concentration of a solution of 6 molar. We know that the mass that we actually want to get to is 23.4 grams. This should say grams. Question is, does this matter? And the answer is not at all. Reason being, if we can get to this value, we were told that this value would produce this 40 grams. So in other words, get this number, and then you know, based on the problem, it will give this number. So our approach is actually going to be to ignore this particular value. We're going to use the concentration of the solution, the volume we were given, to get moles first. That's what molarity is all about. So we're going to get moles first. Once we have moles, we're going to convert our moles to grams. And we're going to see how much we actually end up producing. Okay, all right, so let's do the math. All right, molarity. So I'm going to do the 6.0 will equal X over 5. So I'm going to multiply X times, I get X equals 6 times 5 is 35, right? Sorry, 30. My 30 moles is going to produce exactly how many grams of KCl. So this was step 1. So we're going to say check. Step 2 is going to be convert this amount of moles to grams. So I'm going to erase some stuff on the slide so I can have some room to work. So again, we want to get this into grams. Okay, so what do we need to go from moles to grams? We need a molar mass. All right, so we're going to convert that number by getting the molar mass of the K2CrO4. So those of you that need that, walk through. I'm going to do that on the side of the screen. Those of you that can find it on your own, you can just skip this part. We're going to do 2 times potassium, which is 39. We're going to do that plus the chromium atom, which on my periodic table weighs 51.996. We're then going to add the oxygen atom times 4, so 4 times 15.999. $78.196, and 4 times 15.9. Woo! No, go back. All right, so I got 194 point. Why does it keep doing that? 194. Oh, okay, all right. That is frustrating. All right, I got that 194.188 grams per mole. More mass. Okay, so now I'm going to use that molar mass. Those of you that want to come back, now we're going to use that molar mass to convert our number of moles of the K2CrO4 solution that we started with to grams. Okay, so here we see that we got a huge number. Our goal was this number. This is how much we actually need. So this particular approach was not going to be the complete approach. And so what we're going to do is we're actually going to take a second and we're going to try this again. And we're going to look at this from a different approach. In other words, I'm going to try to work backwards. I'm going to say that I know I need this amount of grams, which means I need a certain amount of moles. And in knowing I need that certain amount of moles, I'm going to try and calculate exactly the volume that I need from this particular solution. Okay, so going back, our goal, was 23.54 grams of the potassium chromate. And we have 6 molar, and we have of the K2CrO4, sorry, and 5 liters of it. We won't need 5 liters. We just calculated what would happen if we tried to use 5 liters. So we actually want to figure out what volume will we need to actually only get this amount of moles. So we're going to convert this number of grams. Sorry, let's try our different approach. Our first approach is actually going to be to convert coal mass to moles. Then use molarity formula to calculate volume needed. And from the previous slide, I just want to remind you that the molar mass of K2CrO4 is 194. Write that down. Okay. All right, so now we're going moles. Sorry, we're going grams to moles. When we do that math, we're going to get 0.121 moles of K2CrO4. So what we just calculated is the amount of moles of K2CrO4 we actually need from this given stock solution. Now we have a lot of it. We're not going to use 5 liters. We're really going to use quite a bit less. So now what we're going to do is we're going to use the molarity formula. We know that the molarity of the solution is 6 molar, but we also know that instead of 5 liters, we want 0.121 moles of K2CrO4. Now, that being said, we don't know how many liters that's going to end up being. We just know that it should equal 6 molar. So we're going to rearrange this formula to solve for X. And that's going to give us the volume in liters. So in your calculator, you're going to do that math and you're going to get this volume, which sounds really small, but in reality, this is 20 milliliters. We're not doing a huge calculation where we want to use 5 liters of solution, 5 liters being 5 very large beakers of this liquid. We don't need that amount. We needed much less. And so we are actually going to calculate that we only needed 20 milliliters to do this given goal of our particular problem. And that brings us to the end of the practice problems on molarity. Remember that you can always use the formula to help you manipulate what you need. That is exactly what we did here in this problem. Now, also remember that sometimes you may set up a problem that doesn't look as straightforward as it ends up being. So like that third one I just did, make sure you know what you're actually looking for when you're doing your math. All right, that's it. I'm going to pause for this. I'm going to upload this one separate of our molarities.